Think about the AI race for a moment. Every few weeks, we see a new model name. A few benchmark numbers go up, prices change, and everyone starts asking the same question: which model is ahead now? But Gemini 3.7 Flash is interesting for a different reason. It is not just another model release. It may be a clue about how Google is approaching the next phase of the AI race, making smaller, targeted improvements frequently, while potentially working on something much larger behind the scenes. Look at the timeline. Gemini 3.6 Flash was released on July 24, 2026. Then, just 23 days later, Google introduced Gemini 3.7 Flash. That is a surprisingly short gap. Google is not presenting 3.7 Flash as a massive increase in model size or a dramatic expansion of context. Instead, the focus is on algorithmic improvements, reasoning behavior, execution discipline, tool use, and agent performance. In other words, Google appears to be optimizing the engine, rather than simply making the engine bigger. And that distinction matters in current AI landscape. Because the future of AI may not be about releasing a completely new giant model every few months. It may be about continuously improving the same underlying system. Look at this comparison. Gemini 3.7 Flash keeps the same 1 million token context window as the broader Gemini 3 generation, while supporting text, images, audio, video, and complex PDF inputs. But the interesting part is what happens when we move from traditional chatbot tasks to agentic tasks. This is where the numbers start becoming much more interesting. On DeepSWE version 1.1, which evaluates long-horizon software engineering and bug fixing, Gemini 3.7 Flash scores 65.3%. Gemini 3.6 Flash scores 48.6%. That is a jump of 16.7 percentage points. This is not a tiny improvement. The model is being asked to work through software problems that require multiple steps, identify what is wrong, make changes, and actually move toward a solution. And this tells us something important. Google is not simply trying to make Gemini better at answering questions. It is trying to make Gemini better at doing things. That distinction becomes even clearer when we look at agent benchmarks. On Terminal Bench 2.1, Gemini 3.7 Flash scores 85.8%, compared with 78% for Gemini 3.6 Flash. On Automation Bench, the difference becomes even more dramatic. Gemini 3.7 Flash reaches 30.4%, compared with 17% for 3.6. Look at this table. You can see that the biggest improvements are appearing in exactly the areas that matter for AI agents: terminal interaction, workflow automation, computer use, and multi-step execution. And that is probably one of the most important things to understand about this release. Flash is starting to mean something different. It is no longer just the smaller, cheaper model you use when the bigger model is unnecessary. It is becoming the model you can deploy everywhere. Imagine an AI agent running continuously, reading documents, calling APIs, searching the web, editing code, operating software, checking results, trying again when something fails. In that kind of system, intelligence matters, but speed and cost matter just as much. And this is where Gemini 3.7 Flash becomes particularly interesting. The model reaches around 340 tokens per second. That is extremely fast. And at high thinking mode, the average completion time on the benchmark set is reported at around 1.7 minutes, which is about 40% faster than GPT 5.6 Tera on its maximum setting. So now look at the bigger picture. On one axis, you have intelligence. On another axis, you have speed. And on a third axis, you have cost. The winning model for an agent does not necessarily need to be number one on every intelligence benchmark. It needs to provide the best combination of all three, and this is where Google seems to be positioning Flash: fast enough to feel responsive, smart enough to perform multi-step tasks, cheap enough to run at scale. That last part is particularly important. Look at the pricing table. The promotional API price listed in the model cards is 75 cents per million input tokens and $3.75 per million output and thinking tokens. That makes the economics substantially more aggressive than many frontier models. The blended cost may be roughly 1/3 of Claude Sonnet 5 and GPT 5.6 Tera at the promotional rate. Now imagine the impact of that at scale. An individual developer might save a few dollars, but an AI company running millions of agent interactions could save an enormous amount. And this is why the phrase workhorse model is important. A workhorse model is not necessarily the model you use to win a benchmark leaderboard. It is the model you can afford to keep running all day. Now look at another feature: context caching, a 90% discount on cached input reads during the promotional period. That sounds like a pricing detail, but for agents it can be a major architectural advantage. Imagine an AI coding agent working on the same repository. The documentation is the same. The The project structure is the same. The configuration files are the same. The policy documents are the same. Instead of paying full price to repeatedly process that context, the system can reuse it. So suddenly, model intelligence and infrastructure economics start becoming connected. And this is where I think Gemini 3.7 Flash tells us something bigger about Google's strategy. Because look at how many places this model is being pushed into immediately. Google AI Studio, Vertex AI, the Gemini API, GitHub Copilot, Devin, Google Antigravity, Gemini Spark, and enterprise platforms such as Databricks and Box. This is not just a model release, it is a distribution strategy. Google is trying to put the same intelligence layer into as many workflows as possible. And there is another interesting detail. Gemini 3.7 Flash reportedly became the primary engine for Gemini Spark, Google's always available personal agent. That makes perfect sense. A personal agent cannot economically behave like a massive reasoning model for every single request. It needs to be fast, it needs to be cheap, and it needs to be good enough to perform dozens or hundreds of small actions throughout the day. So 3.7 Flash looks almost purpose-built for that future. Now let's look at multimodal performance. On the GDP.PDF benchmark, Gemini 3.7 Flash scores 34%, up from 22% for Gemini 3.6 Flash. This shows an improvement in understanding technical charts, complex financial tables, and dense PDF documents. On long video understanding, the model reaches 85.4%. And on the 128K long context retrieval benchmark, it reaches 97%. But notice something interesting when you look at the full benchmark table. Gemini 3.7 Flash is not number one everywhere. On some tests, other frontier models remain ahead. For example, on DeepSWE, GPT 5.6 Terra is still higher. On some scientific reasoning benchmarks, Claude and GPT variants also remain very competitive. And that is actually important, because this release is not proof that Google has suddenly crushed every competitor. It is proof that Google is becoming increasingly competitive across a very broad surface area, and that is a different kind of strength. Now let's get to the most interesting question. Why is Google releasing updates this quickly? 3.6 Flash, then 3.7 Flash only 23 days later. Could this be the new normal? I think there are two possible interpretations. The first is straightforward. Google may simply be moving toward much faster model iteration. Instead of waiting for one giant breakthrough, Google can continuously improve reasoning, tool use, inference efficiency, and reliability. Think about a smartphone. You do not redesign the entire phone every month. You improve the camera, then battery efficiency, then software, then the processor. The same philosophy could increasingly apply to AI models. The second possibility is more interesting. Google could be using these smaller releases as stepping stones, while a much larger update is being developed internally. That would be speculation, but strategically, it would make sense. A company can improve its existing models publicly while its next major architecture is being trained privately. In fact, these smaller releases could provide something incredibly valuable: real-world feedback. Every new Flash version can test new reasoning techniques, new tool use strategies, new inference optimizations, new agent behaviors, and once Google understands which improvements actually work at scale, those lessons can feed into a much larger future system. So the small updates may not be distractions from the big model, they could be part of the path toward it. Look again at Gemini 3.7 Flash. It specifically highlights dynamic thinking levels: low, medium, high. That sounds simple, but it represents an important direction. Instead of treating reasoning as one fixed behavior, the developer can decide how much reasoning effort a task deserves. A simple extraction task does not need the same thinking budget as a complicated software engineering problem. That means future AI systems may behave less like a single model and more like an adaptive computing system. Easy problem? Think less. Hard problem? Think more. Need speed? Reduce reasoning. Need accuracy? Increase reasoning and tool validation. That could become one of the most important design patterns for agentic AI. And when you combine that with fast inference, cheap tokens, caching, tool use, computer control, and long context, you start seeing where Google is going. Not simply better chatbot, but infrastructure for large numbers of autonomous agents. So, what should we take away from Gemini 3.7 Flash? First, Google is clearly pushing the Flash family beyond the traditional idea of a lightweight model. Second, the strongest improvements are increasingly appearing in coding, automation, document understanding, and multi-step agent behavior. Third, speed and price are becoming as strategically important as raw benchmark intelligence. And fourth, the rapid jump from 3.6 to 3.7 may indicate a broader change in how frontier AI models are being developed. Smaller public releases, continuous optimization, constant feedback, and potentially much larger architectural jumps happening behind the scenes. So don't look at Gemini 3.7 Flash only as the new Gemini model. Look at it as a signal. The AI race may be moving away from giant announcements separated by long periods of silence. Instead, we may be entering a phase where the leading companies continuously tune, ship, measure, learn, and ship again. And while everyone is watching the leaderboard move from one model to another, the more important competition may be happening underneath it. Who can build the fastest reasoning engine? Who can run the most capable agents at the lowest cost? Who can connect those models to the most useful tools? And who can turn every small improvement into a much bigger system? Gemini 3.7 Flash suggests Google is taking that strategy seriously. And if these small releases really are stepping stones toward a much larger Gemini update, then the model we're looking at today may not be the main event. It might be one of the clues that the main event is still being built. That's all for today in Dots and Arrows. Thanks for watching.